Welcome to Bite-Size Data Science. In the previous video, we saw that we can select data based on intersecting geometries. What else can we do with spatial objects? We've looked at spatial data using the GeoPandas library. Here's an example of the column types for the GeoPandas data frame after reading the Census Bureau data for the roads in Multnomah County in Oregon. We see examples of records at the bottom of the screen. The geometry columns has a type of geometry. We need to dig in further. If we retrieve the type of a specific geometry, we see that the specific type comes from the Shapely library. We can find out what can be done with geometry objects by looking at that library. Shapely provides the following object types. We are already familiar with point, line string, polygon and multi-point, multi-string, and multi-polygon. The linear string object type can be considered a line string that is either explicitly or implicitly closed. Finally, the str3 object type is a utility class that allows for the creation of an R3 index and the querying based on the index to speed up retrieval. Spatial objects have multiple attributes. Most of these attributes are pretty clear. We can find out if an object is valid or empty, for example. I want to point out the has_z attribute. This indicates the object can be three-dimensional. The boundary attribute returns another spatial object, and the centroid is a point representing the center of the object. The WKT and WKB attributes are also objects that can manipulate the well-known text and well-known binary object representation. There are many methods available, and several of them are obvious. Methods like intersects, overlaps, touches, within, and contains are Boolean operations. Other methods such as difference, intersection, convex hull, and union return other spatial objects. The last one I want to point out on this page is buffer. As its name implies, you can create a new object that will contain the original one with either a positive or negative buffer around it. This way, we could, for example, add a width to a road instead of being just a line. The second page includes the remaining methods. Note that I also added a few methods from the speedup module that allows for the use of the geos library that is written in C++. Let's get into a notebook to see some of these operations. I am using the IBM Watson Studio environment to run my notebook. If you are interested, you can find a link in the description on how to create a free account on that platform. Links to the notebook I am using here are also available in the description. In this notebook, I'm using data from the Census Bureau where I work with roads data from the Multnomah County. I first get the list of states so I can get the state code for Oregon. Then I extract the US counties and found the counties for Oregon. We're getting a visual on what Multnomah County looks like. Now that we retrieve the state and county codes, we can go read the data on roads from that specific county. I removed the roads that did not have a name, and we get a total of 12,059 roads. The partial display of the records shows that the roads are represented by line strings. Let's take one specific street as an example. We can look at some of its attributes: type, length, area, bounds, and representative point. Here's an interesting difference. We have the ability to get the multi-line envelope that is a rectangle that includes the object. There is another similar attribute, minimum rotated rectangle. The obvious way to see the difference between the two is to look at the area of the resulting object. The minimum rotated rectangle is quite a bit smaller than the envelope. That is due to the fact that the object we are looking at is not purely vertical or horizontal. Here is a map representation of both objects, where we see the envelope covering the min and max of the longitude and latitude of all the points that are part of the line string. One more thing to note about these bounding boxes is that we see that the street continues past the western limit. This is probably because it is the county limit. Something to keep in mind if you need to work on streets that cross multiple county lines. Finally, I'd like to point out an interesting difference in operations. Intuitively, we may think that a method intersects and crosses would return the same result when dealing with roads. It turns out that the intersects returns 74 roads that intersects with West Burnside Street, including itself. When we try cross, we end up with only 5. All this to say that we always need to know exactly what the method does so we are not surprised by the results we get. Spatial objects are complex and there is a lot more to learn about them. See you next time on Bite-Sized Data Science, and don't forget to subscribe.